Hello and welcome to this briefing. Today we are going to speak about the operation on high altitude airports. The objective of this video is to share with you some good operational practices for this type of operations. This presentation is divided in 4 parts. The first part is about the oxygen supply for flight crew and passengers. The second part is about how not to exceed the max tire speed. The third part is about the different possible packs configurations for the takeoff and their impact on aircraft performance. The fourth part is about the cabin pressure management.
The oxygen requirements for the flight crew and passengers are defined by the local regulations. So, please contact your local authorities in order to identify your specific needs in terms of oxygen for flight crew and passengers. If supplementary oxygen is necessary to comply with the requirements of the authorities, Airbus can provide customized solutions for the flight crew and passengers. This oxygen concentrator is one of those solutions. It can carry up to 6 pounds of oxygen. Operators report exceeded maximum tire speed at high altitude. The reason for this are high altitude, high ISR temperature, and unexpected tailwind component. This is also often associated with erroneous rotation technique, under rotation or late rotation. Today, if the tire speed goes above 195 knots, the AMM requests the removal of the tires. In order to avoid an exceeded tire speed, Airbus recommends the following. To perform a correct rotation technique, for more details, refer to WinVideo What About Rotation Technique, and to respect the performance calculated speed based on the fact that the performance calculation takes into account the tire speed limitation. At high-altitude airports, the takeoff cannot be performed with packs off, due to the risk of triggering the cap press excess cap al master warning. If the flight crew wishes to improve the takeoff performance, it is possible to perform the takeoff with one of the following configurations. Both packs running, supplied by the APU bleed, or one pack running, supplied by the APU bleed. On this example, calculated at the Chingatse Peace Airport, the use of APU bleed instead of the engine bleed can increase the max takeoff weight by 1 ton. The general objective of the cabin press management system is to keep the capability to detect any abnormal loss of cabin pressure, and at the same time to avoid any spurious cap press excess cap alt master warning triggered by the high airport elevation. In order to satisfy this objective, several aircraft configurations are available depending on the airport elevation and indicated in this illustration. Each aircraft configuration has a specific procedure. This is the reason why Airbus recommends to follow the specific procedure described in the FCOM, according to the specific aircraft configuration.
To end this briefing, we would like to emphasize that the SOPs are the standard to operate Airbus aircraft. This video is focused on the supplementary procedures for operations at high-altitude airports. Please review the specific aircraft configuration and specific procedures for high-altitude airports as described in the FCOM. We hope that you have enjoyed this briefing and see you around for the next one.